Today we're going to be going over limits and different types of discontinuity. So this is our first type of discontinuity. It's called a whole discontinuity. And we can find the limit of this by doing limit as x approaches -4 from negative infinity, from the negative side. So x approaches -4 from the negative side, well, from negative infinity. So negative infinity is all over here on this left side. So negative infinity approaching -4, so it'd be going this way. And that would be at -5, because this would be getting right here at -5. So the limit of x approaching -4 from negative infinity of f of x is -5. Now we can also do it from the right side. So now we have the limit of x approaching -4 from the positive side, or from infinity all the way to -4, which would be coming that way. So the limit of x approaching -4 from the positive side of f of x would again be -5. And one last thing we can do is we can find the limit of f of x at x, not approaching, but x just at -4. And why not approaching? Because there's nothing here. So just at x at -4. And that would just be -5. Even though there's not a point here, it's still approaching -5 because that's the limit. And how we could also tell this is we can find the limit from the left and the right. And if the limit from the left is equal to the limit from the right, then that would just be -5. It would be the same thing, and also you would prove that there is a limit at this point. And now we're going to be also now finding the continuity, finding if point at -4, x equals -4, is continuous or not. So now there's 3 steps to find if this point is continuous or not. So the first step is to find f of -4. f of -4 is nothing. It does not exist because there's a hole here. But if I filled it in, then it would be -5. But since it's an open circle, signifying there's no point here, it would be does not exist. Now we could actually stop here because we found this point does not exist, and we would find that it's not continuous. But I'm going to go ahead and show you the rest of the steps. So step 2, finding the limit from the left and the right. So we did that previously, so I'm going to quickly go through it. Limit from x approaching -4 from the left of f of x equals -5. And the limit of f of x when x is approaching -4 from the positive side is also -5. And since now we have these two, we can also prove that the limit of x going to, not x going to, at x is at -4 of f of x is -5. Since we proved that the left side and the right side, these two are equal to each other. And then the last step is we now find this limit and we set this equal to each other. But these are not equal, meaning this is not continuous. So I'll just go ahead and write out the third step for you. The limit of f of x at x approaching -4 is not equal to f of -4, meaning f of x is not continuous. So now another way we can find the limit at x equals 2 for f of x is plugging in points through a graph. So you have to make sure that when the numbers are closer and closer to 2 from the left side and the right side. So they have to be really, really close to 2. So these numbers work. And then you would do this if you don't have a neat graph like this that clearly shows you what points you're trying to get at. You would do this if you're given a function which you can plug in values to using a calculator or just doing it by hand. But I'm just going to make up values since I don't have a function to plug into, and you'll find that it actually gets closer and closer to 3. So this would be 3.07, and then it gets just a little bit bigger. And then you would find this gets really, really close to 3. And you would eventually, your graph would look something like this, just getting closer and closer to 3, and then that would just be your limit.